hang out here and listen, and then we'll get things going here.
All right, looks like we are live.
We are live. Yeah, we are live.
All right.
Live-ish.
Live-ish.
I don't see anyone showing up yet. Oh, there we go. 13.
There we go.
Welcome, everyone.
Yeah. Hello.
Yeah, I was starting to worry that something we said yesterday.
Good morning, good afternoon, good evening, good night to some of you, and welcome to day 2 of the Leonardo Group Toyota event. Numbers are climbing quickly, and we probably won't go through introductions today. You remember from yesterday, I hope. And we're going to give everybody 1 minute or so to join, and then we will get going with the introduction before we toss it over to Tom and Trisha to give us the tour. Today is a really exciting day, and again, a reminder, please post your questions in the chat box, and we will be gathering those and putting together a list of questions for Tom to answer tomorrow. Richard and Tom, do I have you there?
Yeah.
Yes.
Hey, if anyone is from an exotic location or not, why don't you check in the chat box. Let us know where you're logging in from. Let's make sure that's working.
Have a look at the chat box.
I know I got an email from some folks from Asia saying, "Gee, this is kind of inconvenient for us. Sorry about that."
All right.
It's 2 a.m. I think in Japan.
So while we are waiting, numbers still climbing. So we're going to give everybody
a
second or so. So I'm going to go ahead and mute myself and turn off the camera to give everybody a minute, and we will get going immediately.
Anastasia, welcome. Some familiar names here. Oklahoma City, know it well. Darien, Wisconsin. Phoenix.
Tijuana.
All right. Okay, you can hear me, Tom, right?
I can.
Yeah.
Can you hear me?
Yes.
Oh, there I am.
And I can hear Gerard.
Yes.
Can you hear us, Gerard?
Yes,
okay.
I can. Numbers keep climbing.
It's nice.
Okay, from Brazil, John Deere Construction and Forestry Division.
Oh, John Deere, Brazil?
Yeah.
That's where I got this from.
Yeah.
I always get a question of two, folks. This is called a mate, and you will see me drinking out of it every now and again. It's very good for you.
Yeah, that's the most colorful
antioxidants and
the most colorful cup. And here's the most uncolorful cup.
Yes. Yes, this was a present from my friends at John Deere Montenegro. Thank you.
Okay, Barcelona.
Oh, beautiful, Barcelona.
Yeah. Okay, so I think we can get started. What do you think?
Yeah.
All right. Hey, one thing I wanted to add to our analogy yesterday. We were talking about building your dream home. And we talked about how if you're just remodeling a house that you bought, you can make it better for sure, but it probably is not going to end up being your dream home because you're starting with the foundation, right, that someone else really designed, or maybe they didn't design it that well. But we left out one scenario, which I think maybe is more common. And it comes up in our household because my wife is an architect, and Gerard has a brother who's an architect too. So one of the games we play occasionally when we're bored and driving around is my wife will identify owner-designed homes. Just by driving around a neighborhood, she'll go, architect, owner-designed. And what she's referring to is cases where people wanted to save money. I don't know of any other rationale really, but wanted to save money by designing their own home or buying, a set of plans and just kind of doing it themselves. Or maybe some people are just inherent do-it-yourselfers, right? And they just wanted to. And architects take a healthy chunk of, a healthy fee. But my wife, who's a trained architect, can just look at that house and say, amateur, right? Owner designed. And so can we make the same kind of determination with factories and assembly lines? That's what we're going to be talking about today, Gerard and I, is owner designed assembly lines that didn't follow the mixed model process or the Toyota production system philosophy and just use their common sense to put together an assembly line and oftentimes make some mistakes. So one of the things we're going to be talking about now is some of those bigger mistakes that not that are theoretical, but that Gerard and I have seen, right, have had to deal with out there in the world over the last 20 years. Some of the more interesting ones, and not just talk about the what happened, but share with you the actual case history for 10 of these.
Interesting you mentioned that, Richard. Yesterday, one of the names I saw flashing in front of us of all the people that were signing in is of my friend Nathan Lovelli, who works for Apple. And I remember him telling me once, hey, I visited this factory. He got a factory tour at one of our clients, and he says, I saw your fingerprint on that line design.
Well, clean it off. Lack
All
of
right,
5S.
so what do you say we get going?
Okay, let's launch our slide presentation.
So today, you're going to be seeing the line led by Tom and by Tricia, and for that reason, I want to talk about line design. Of course, with the very limited time we have allotted for this, we cannot walk you through the line design process. All of you that are members of the Lean Design Studio have access to that. We're not going to bore you with that information. Those of you that are not members, please consider joining. What we want to talk about is this issue that Richard was just mentioning of design by an amateur versus design by a professional or by a trained person. And we want to talk about 10 mistakes that we see when we visit potential clients or factories, and we see these mistakes that get in the way of allowing your line to become a competitive advantage. And hopefully we'll tell you a few things on how to avoid them. So
yeah, and we considered changing the title yesterday to 10 Greatest Treasures.
Yeah, exactly. based on Tom's point that it is true. They really live by this creed, right? That when there are no problems, that's a big problem, right? They are always looking for those treasures because that is the opportunity to improve. So yesterday we were reviewing this presentation and we did think about 10 biggest treasures. So you can look at it that way. 10 biggest opportunities. So first of all, when we talk about line, we're talking about a production line, right? A typical manufacturing line. Now we have applied our techniques to lines other than manufacturing. We have done this in administrative settings and in healthcare settings. So when we talk about line design, is short for designing the workflow, the flow of the product in linked and balanced processes and workstations. So this is all wrapped within the umbrella of mixed model line design. So we're going to be using, the short of line, the short of line design to signify workflow design and mixed model line design. So understand that to us, that's the only kind of line that we look into. So with that, let's jump into first, or the 10th mistake that we want to discuss with you.
Yeah, and this picture may give Tom Lego PTSD.
A nightmare.
Yeah. If you can recognize that, Tom, it's the aluminum pieces for the so-called desktop organizer.
Yes, that brings back a lot of memories.
Yes. I'm sorry, folks, for the inside joke, but at one point in time, we were teaching the classes at Toyota, and we were using this teaching tool, which we call the desktop organizer. It was a bunch of extruded aluminum, a Bosch extruded aluminum that we shaped into kind of a desktop organizer with boxes and stuff, right? And that was shipped to the plant at Toyota that yesterday you saw during Tom's presentation. It was shipped on 4 or 5 gigantic wooden crates.
More than that. I think it was more like 10 or 12.
Enormous wooden crates. So that was really, really testing the generosity of the Toyota team.
Hey, they're material handlers, right? Material handling. So
yes,
what's the big deal?
So we have since then corrected our ways. We are much better people now than we used to be. We don't do that anymore. And by the way, we used to tell folks, hey, if you want to take it home, take it home. And not a good idea. You don't want to carry a bunch of pipes in your carry-on bag when you're about to fly back home. First one, or 10th one of them, this is a big one, designing from the conference room. Not going to the floor to see how the processes are, how the processes go together, and thinking that information that you will glean of your MRP, ERP, or your spreadsheets will give you all the information you need. You must spend time on the floor. Doing everything from the conference room will not get you there. Will get you something that works in here, but then when you bring it live, and nobody will understand it, and the folks that have to do the work will be tremendously confused. So the solution is pretty simple, right? Go to the floor, interview the operator, ask respectful questions. This is something that really irks me when I see people looking at how others do work and referring to that work in disrespectful manners. That is not okay. When operators do work in a certain way that looks like a workaround, the workarounds do exist for a reason. And actually, I lay it at your door, your line designers, because you didn't design it correctly and folks had to resort to a workaround. So do all the data gathering by spending time on the floor. Every now and again, you're going to have to spend a little bit of time in the conference room, but the floor, every day you need to be on the floor checking the quality of your data. So,
do you remember there was a movie, Crocodile Dundee? A lot of you have seen that.
How could I forget?
And there was a scene in there, probably the best known scene of that whole movie series, where he's mugged. You know, there's someone trying to rob them in an alley with a little knife. And Crocodile Dundee pulls out this huge blade and says, "That's not a knife. This is a knife." And we had a similar experience on this topic. I think it was at John Deere, but that was a long time ago, Deere. So don't get offended. But we went out there with the process documentation that they had, and one of the operators said, similar to, that's not a knife. This is a knife. He said, "That's not the process documentation. Here's the process documentation." And he pulled out a handwritten notebook, right, that he kept in his drawer, where he had handwritten notes of how to actually build the product, not the way it was documented in the system.
And actually, the case study that we have on this one, for each one of them, we're going to tell you a story. And Richard just added one. And the story on this one is one of mine. Working with a large corporation that has one of those leadership programs, right? They gave me all the best and brightest, and really, really bright guys. And from 1 week to the next visit, I told them, okay, folks, I need you to go out and build me all the process flow diagrams, so we can move on to the next step, which is building the process flow matrix. And I came back and they hand me all the process flow diagrams, and I picked them up and they hand me paper. So I said, okay, guys, let's go to the floor to check them. I go, wait a second, no, we're going to check it against the routings. Oh, no, we're going to check it on the floor. So I go to the floor. I'm standing in front of this gigantic piece of equipment, which was a gas turbine for power generation, and I'm following the process flow diagram, and the operator walks behind me and says, "Nah, that's not the way it's done," and passes by and walks away and go, "Wait, come back, tell me." And the guy was open enough. He said, "Listen, if we were to do it the way it's described in the process documentation, we would never finish. These are the workarounds we take to make the product flow." So I look at the team and I said, "Did you know about this?" "No, we didn't, because they are supposed to do it." And the guy replied, "Yeah, I understand. But if we did, this would happen, and this is how it would be blocked." Listen, I'm not condoning workarounds, but if they're happening for a reason. You could say, well, in some cases, they are happening because bad habits. I don't disagree with that. Sometimes bad habits get in the way. But in most cases, I have found that the folks on the floor, the associates on the floor, are trying to do a good job. I don't know of anybody who's really trying to do a bad job. Of course, I know one or two that are rotten apples. I understand that. But the majority of folks, and if you approach it with respect for people, they're trying to do a good job. So it's up to us line designers to give them a good line. So that was one of mine, and we have more of these. So we're going to leave it at this one, but make sure that you check the quality of your data on the floor. And if there is a need to correct the data, make sure that you put that feedback loop in place.
Okay, you notice we're going backwards here. So this is a kind of a David Letterman top 10 style. So now we're at 9. We started at 10. Now we're at 9. Okay, the issue here is the term process and what we mean by that, because that's kind of an open-ended word, and there are two mistakes you could actually make when documenting a quote-unquote process. And when would you ever do this? Well, you do a value stream map, right? And on a value stream map, you would have a box, which we call, interestingly enough, a process box, right? So you have to know what goes in that box. That's an important thing to know. And then in the mixed model manufacturing methodology, we use a kind of a simplified value stream map called a process flow diagram, similar but simplified for every individual product, where we need to understand the flow, because it can be different. Even on the same assembly line, you can have variations in the flow. So we need to know that. Now, here's the issue. If you make a mistake in defining what a process is, you can either go one of two directions. You can either be too high level, too general. For example, is manufacturing a process? Well, yeah, kind of, sort of, but it's way too high level. There's not much you can do with that by having a box that says manufacturing, not enough detail. The other mistake, which is probably more common, would be to have too much detail. So instead of a process, you're defining or including in these boxes a work step that's part of a process. It's a subset of a process, but it really shouldn't be defined on its own. shouldn't be called a process by itself. So too high level, correct, but useless. Too low level, overwhelmed with too many boxes, basically. So the issue here, or the challenge for us, and I'll have to admit, when I first started working in this arena, it took me a while, and I was doing this, fairly often. It took me a while to kind of get it, to kind of grok what a process is. I think I understand it now. But it may take some practice to get a sense of what's included in these boxes. Either on a value stream map or on a process flow diagram, it's the same definition, right? Same level of detail of process. And if you can achieve that correct definition of a process, then you're going to have a correct level of detail, right? You're going to have a correct value stream map or a correct process flow diagram. So here's what we mean by a process. It's usually work of the same type of work. So if we're doing some assembly work and we're doing some sub-assembly work, probably that's not the same process, because that work can be done in a different location. One is consumed in the other. So that would typically be two processes, or assembly and then it goes to quality, or assembly goes to test, or welding goes to assembly. Those are different processes because the type of work that's being done is different. Okay, so that would be one dividing line. The work within a process is usually sequential. It's happening one step after another, because if it's happening at the same time in parallel, then you could have that done by two different people, right, in two different locations, and it's not a problem. So normally the work is sequential work. Step 1, or 10, 20, 30, 40, 50, all that can go into the same process box. When we talk about equipment or machinery, you can have more than one type of machine in the same process box, but it starts getting complicated. So our recommendation, it starts getting complicated further downstream when we have to calculate how many of these machines do we need. If we have more than one machine, major piece of capital equipment in the same box, the same process box, then we have to do some subdividing. It starts getting a little bit messy. So our recommendation is don't mix them. So if you have a major piece of capital equipment, not a screwdriver, right, but a major piece of capital equipment, give it its own process box, just to keep things simple when it gets to resource calculations. And the last thing is maybe the most challenging thing to understand. The work in a process box has a constant volume. What we mean by that is not that the volume can't change from day to day in that process. It means that when we're designing the process, we're making some assumptions about mix and volume for design purposes, and that assumption is not changing when we go from one work step to another. It's constant within that box. So if we want to get 100 units out of this process, that 100 doesn't go from 50 to 100 to 75 within that same box. If you do have that change, then you need to define a separate process box, right? Because you can have changes in volume, but you just have to define that as a separate process. And that ties to the more technical concept of when we come to calculating takt time, something we'll get to a little bit later on, then you need to have volumes. And if that volume's changing, then you'd have two different takt times for the same process, which is a no-no. So I hope I haven't confused you already.
Actually, when we teach this in class, we come at it from multiple different angles, but the bottom line remains sequential work of a like kind at constant volume. Sequential work of a like kind at constant volume. Why the constant volume? Because one process, one takt time. One process, one takt time. There are no multiple takt times in one process. One process, one takt time. If you forget everything else we say, one process, one takt time. And with that, you're golden. And by the way, never say the product takt time. Takt times do not have, products do not have takt times. Products have work content.
Now, of course, you can change the takt time in a process. That's a redesign effort. And that's something that many companies, including Toyota Material Handling, do periodically, right, to adjust the takt time to the change in demand, customer demand. So that is something that is pretty much inevitable that you're going to have to do. But at least for the time being, the takt time, while the line is running within a particular design or demand scenario, that takt time doesn't change. Okay, so case history. So we have a pair of scissors here. The case history that I want to share here is a pretty simple one, but we gave a company, a client, we were working on a project, implementation project, and typically we'll work with the client and then we'll go away and they'll have some action items and then we'll come back, right, some weeks later. So a series of phases, series of visits. So I came back after assigning the job of creating process flow diagrams and defining these processes. And we were putting Post-it notes up on the wall, common thing to do as well, right? So we had some black or brown butcher paper on the wall and Post-it notes and markers. And I came back, and in our conference room that we dedicated for this as a war room, the wall was completely covered with Post-it notes. And I said, oh my goodness, what is this? There were hundreds of notes. And I said, I know for a fact the process is not that complicated. And so, of course, as you might start anticipating, I went over and I started looking at these Post-it notes. And what I discovered is that they'd put basically the entire process flow documentation, right, the standard work documentation at a task level onto Post-it notes. In other words, they defined a work step as a process and documented that all. It took 3 walls to put it up. Yeah. So of course we had to re-educate, right, re-explain, and ended up with something that occupied only a part of 1 wall and not 3.
And that's something we remind people when we teach class, and you will see this in our courses. Value streams are made of processes, processes made of tasks. And the mistake sometimes is to confuse tasks with processes, and tasks tend to be very numerous and processes not that many, because as long as the work remains sequential, constant volume of a line kind, that is one process, not a myriad little tasks.
Okay, so the goal here on this mistake is simply to be well educated and really understand at a profound level what a process is based on the definition we've given you, and use that, and then you'll be in good shape. All right, mistake number 8. Misconnecting upstream processes.
This one, and by the way, Richard, time check is almost, we're almost at the bottom of the hour. We should be at around mistake number 5 here, so we're going to have to move a little quicker. On this one, it is nice to think that we can link and balance every last process under your factory roof, and sometimes that is not possible. There are certain processes, mostly in the area of fabrication, primary processes, where you're building many parts that are of the same kind. Sometimes the fabrication processes cannot be linked directly one at a time because they have changeover times, or they're going to have heat treat, or they're going to have to be painted, powder coated, right? In those cases, linking those and presuming that we can have each part flow one at a time to the line is a big mistake. So in many cases, what we ask is leave those out of the process flow diagram, and we design those separately. So that is the mistake, trying to incorporate absolutely everything into one process flow diagram, starting also with the value stream map. So the solution there is, every time you have a primary process that has changeover or a forced batches like heat treat or a paint system, you need to think about separating that from the line and link it to the line using a Kanban system. In some cases, you may have to set up a supermarket and replenish. You're going to have 2 loops, a replenishment loop and a consumption loop. All right. So over time, by improving on the changeovers, meaning making them shorter, you will be able to reduce the supermarket quantity, reduce the batches, reduce the supermarket quantity. Unlikely you will eliminate them unless you go to some other type of process, like buying pre-painted parts or something along those lines. So that is one. Not every process can be connected one by one to the line. So this is one that you remember, right, Richard? This is the one from Dayton, Ohio?
Yeah, so if you look at something like this is not a complicated product, right? It's just an electric fan. But when you start taking it apart, reverse engineering it, you'll find that there are a lot of pieces. Sheet metal pieces, for example. And those sheet metal pieces typically will go through the same pieces of equipment, shearing, bending, brake, paint, they're going through the same steps. And if you wanted to try to flow each of those pieces, to the final assembly stations directly, you would have to replicate, you'd have to have a shear for each component, right? And you'd have to have a brake for each component, et cetera, and a punch, whatever machines you need, which is ridiculous. That's not going to happen. So the reason we're mentioning this as an example is if you try to do that, if you try to quote unquote flow every single component, you may run into this issue of shared equipment. And what you're going to have to do then is simplify, make your life a lot easier by really considering this as two efforts, as Gerard just said. One is the final assembly process and check, inspection and packing. That's one. And the other is the fabrication pieces, where typically these parts are going into a supermarket of some kind. And that supermarket can be reduced in size over time, but you're disconnecting fabrication from final assembly, where you have a host of shared process steps, and you're not going to be able to flow them all at the same time. So there's inventory involved here. And again, we're mentioning this because we saw this. This is, I guess we can be honest, right, Gerard? Occasionally we get kicked out of a project, or the customer.
It wasn't us.
No, it wasn't us personally, but we know the organization where this project essentially failed because the team was trying to get everything to be connected and flow one piece at a time, one by one. I think Tom will be showing you some good examples of that, where they are achieving this or have reduced those inventories significantly. But this particular project essentially failed because of that mistake. Failed is they didn't go out of business. Failed just means, hey, this improvement project is being discontinued. Right? We're going to go back to however we did it before. All right, next one. By the way, Gerard, I think we have a little more time today. The schedule gives us an hour and a half.
Okay.
So we have a little bit more luxury to tell war stories.
Yeah. Yeah. On this one, Richard and I both have stories of our own. And this one refers to designing optional processes, not taking into account the potential for those optional processes to go over the expected option. So it could be that you're designing for a 50% option. And of course, 50%, if you want to design a line capable of building 100 units, you should design that optional process that feed into a line at 50 units. But that is not always the best option, because sometimes, and on certain days, you will have lots of orders for that option. And if you throttle it only to 50%, then you're not going to be able to respond. So, in that case, the solution is to either be extremely disciplined to sequence that option if you put the capacity at 50 versus 100, this option, unless you sequence to only build up to 50 a day, then you're going to have problems. So that's an option, to sequence, right? Another option is what we call over-resourcing or over-designing that process. You design that process for more than 50 a day. Could be to 75, could be to 100. It doesn't mean you will staff it for over 50, because then flexing can take over. In some cases, having a FIFO lane, a number of in-process Kanbans between the option and the consuming process works. And again, don't need to overstaff it. Don't need to staff it at over the options capacity, but at times flexing will take over and you will be able to work with this. So on this one, this also we teach directly in class, and we call it process over resourcing or process over designing. And I remember the first time I used it, I thought I came up with the idea. Of course, you never came up with anything. Someone thought of it before, but I called it faking the takt time. I said, we need to put a fake takt time on this. And then I said, maybe to teach it, I need to come up with a better term. And it process over resourcing. So let's go to your example, Richard, and then I'll tell my story.
Okay, this was one of these cases where it was kind of embarrassing, but here's the product. What it was a cabinet that had a bunch of components in there. It was like a private cell phone system, a transmitter of some kind for internal use with companies. If you're trying to link a campus together, for example, or maybe a college campus, where everyone has radios and they're trying to communicate. It was that kind of piece of equipment. And they had some optional things you could order for this, including a fan, like a cooling fan was an optional piece you could order. And by the way, they had, when we first arrived there, they had a section of this factory that they called the Gray Forest. The cabinets were painted gray, and they had a bunch of these cabinets over in this part of the factory floor in the Gray Forest. And I said, well, what the heck is the Gray Forest? What is that? What is that? And they said, well, this is where we put the cabinets that we can't finish. We started them, but usually we were missing some components. So we launched the build, but we couldn't actually finish the build. So we put them in the Gray Forest until the parts arrive and we can actually finish the work. Okay, well, that doesn't sound so good. Maybe we can work on that. But more to the point, they had a fan, and they estimated that it was an option, and they estimated that demand for that option was about 50%. About half the cabinets required this fan. And so we naively, again, this is a mistake we're sharing with you, right? We naively calculated resources at 50% of demand. And then you can calculate how many workbenches do you need to build these fans. And then that's what we put in place. Beautiful. Mission accomplished, right? And there were no math errors. We did the calculations perfectly. So on day one, launching, and this was months of effort. So this was a lot of work. And so everyone was very excited and very proud. And senior management was there. And I think they even invited the newspapers, such and such company launching a new factory. So everyone was watching, and day one, unit one required a fan. Right? The first unit coming down the new line required a fan. Okay, no problem. So we the fan was built. In fact, it was waiting there in a little in-process Kanban, and the fan goes in. Well, the second unit also coincidentally required a fan, and the third one required a fan. And it turned out that because we couldn't control the sequence on the fans, it was not a major option. It wasn't something that we could just control so that every other unit got the fan. We couldn't control that. The poor fellow who was building these fans, was sweating. All eyes were on him. Everyone was looking at him because the line had stopped right in front of his station, right, the fan building. And so we pretty quickly realized, whoops, since we can't control the fan sequence, what we're going to have to do is over-resource that station. so that in theory, even if every cabinet coming down the line required a fan, we would not be stopping the line. And so what was required was really not much. We required another bench. There was only one needed to meet this 50% option, so we needed two. And that doesn't mean, as Gerard mentioned, that we overstaff that area. We can have someone come in and fill that extra requirement as needed based on some signals. That's a whole nother topic of discussion. But in that way, we could keep the line flowing. So we were able to respond pretty quickly, but a little bit embarrassing when everyone is standing there watching and those cabinets are not flowing. Right? Did you have another example, Gerard?
Yeah, my story goes back to 1996 when having a home theater system in your house, it was the thing for only rich people. And our client, they were the first ones to come out to the market with an inexpensive home theater system. It went by the name Theater in a Box, and it costed just $1,000, which is just a crazy number these days, right? But a home theater system, what is it made of? It's made of a subwoofer plus 5 satellite speakers, right? It is a center channel, 2 stereos, and 2 surrounds. We decided to build this in a mixed model line where the subwoofer is built on a main line with other woofers, because what's a woofer, right? It's a stuffed box. And it made sense to mix it with other products. But then what happens is that when you calculate or when you figure out the volume on the main line, the volume of the line of the process that builds the satellites, it was only 67% of capacity. Had we designed that at only 67% capacity, we would have missed, which we didn't, a major milestone, which was we needed to design this line, especially because it was a new product, to be able, which was a term at the time I learned in the retail business, to stuff the channels. We needed to stuff the channels, meaning we needed to flood the market and make sure that Best Buy, and at that time CompUSA, and all those retailers had inventory. So that line, even though it was designed for a mix, it was going to have to run pretty much all the time, or maybe 90% of the time, building home theater systems. So at that time is when I coined the term in my head. I said, we need to fake the tag time in the satellite process. So we faked the tag time. Basically, I forced the tag time from the main line into the feeder, and in that way, we never missed a beat. So that is my story, and then again, that's another way of dating myself.
Okay, some more treasures here.
Yes.
Excessive operator part selection.
We are and shall remain for a very long time to come big fans of Kanban. We are. Kanban is an excellent methodology. You will see that the folks at Toyota use it, but we cannot put a number on this. But sometimes you go out to the floor and you see a sea of Kanban racks, right? Which sometimes people insist on them to be in racks, right? Kanban racks, in Kanban everything. And sometimes that is not necessary, and that increases the risk of mispicking, using the wrong parts, having to walk too much to get to the right part. So if you observe, and you should spend time observing, the associates on the floor spending too much time walking around hunting for parts, even though your material presentation is good, even though you have pretty much everything on Kanban, then you need to start thinking about maybe dialing that down. Now, if you're not even using Kanban and you're presenting materials in bulk and you're bringing entire pallets and gailers and stuff like that, okay, you have a steeper hill to climb. You have more work to do. Definitely get out of that one. But you need to observe how the folks are acquiring materials and then start considering other methodologies like sequencing parts, like presenting sets, like presenting kits. In that way, you will provide the associate with the material they need when they need it, and not having them to go look for those materials. So the shorter the tag time, the less forgiving the process is, the less time you have to acquire materials. So those of you in high volume environments, you really need to make sure you dial this down correctly. Solutions, again, provide what's needed, right? And provide what's needed means evaluate material presentation techniques or material replenishment techniques other than, again, forget all the old style MRP kitting and bulk and all that junk. That's old story. Get out of that. I mean, that is 19th century stuff, right? We're talking about beyond Kanban. Start looking at kitting and sets and material sequencing, and you need to begin from a point of 70% Kanban and 30% everything else, right? And then see if you can reduce that percentage of Kanban materials and increase the number of kits you present, the sets you present, the sequence materials you present. All right. So let's look at our example here, Richard. Richard, did I lose you? Okay, folks, let me check for a second with Richard. I'm going to turn my camera off and check with Richard to see if we are having technical problems. Sorry about that. Hang in there with us. Sorry, folks. Yes, we did have a technical problem, and that was a broadband issue at our main office. As you may have noticed, I am speaking from my home office. Richard is our home office in Boulder, Colorado, and Tom is at his office in Columbus, Indiana, and that's the reason why you see us in different environments. And a second ago, the internet service dropped out of our office, and Richard is joining us back. And sorry about that. You know, that's the kind of stuff that happens, and I'm sure that you folks are pretty used to this, having to deal with Zoom and Teams and all that in the last time. So, Richard, are you back with us?
Yeah. Can you hear me?
I can hear you really well.
Oh, hey, even better.
Excellent.
No
and
improved.
by the way, it looks like you're sharing screens. So please go ahead and transition to the next slide so we can talk about the example on mistake number 6.
Okay. How's that?
Yeah, that looks good. And this seems to be one of yours.
Okay. Let's see. What example were we talking about here?
Oh, the excessive part selection.
Yes. So this came. This comes up all the time, probably on any project. But on this particular one, we were videotaping basically all of the work, the current state. And then we were documenting the work steps based on the video, that we were watching. And one of the tasks that we assigned the team was, let's try to break out the part handling, part selection piece from the value adding piece of each cycle. And by the way, there's software available that make it easy to do that kind of analysis, right? That allow you to videotape a process. And then,
which by the way, again, we're not here to sell you software, but it's actually a pretty decent piece of software. And several of our clients use it. It allows you to take a video, and then you mark the video and document the steps and assign each step to a portion of the video. It's a really, really nice piece of software. Richard, name of it is Time what?
The name escapes me.
Yeah, it's the Scottish fellow.
Timer Pro. There we go.
Timer
Pro. Yeah.
Really nice piece of software. We've seen it in use and works really well. And I've become a fan of videotaping because it allows you to take another look at this kind of waste. And this one that Richard's talking about was a tremendously successful project. In great part because they really did make a quantum leap in the way they were acquiring materials to build a product. They went from having tons of bulk materials, and folks were spending like 40% of their time walking around getting parts, and they went to what would you say, Richard, 75% kitting on that line with the AGVs?
Well, almost 100% in the sense that everything they needed for a unit was right there. Right?
Well, I'm not saying 100% because the hardware was at the was always there, right? But pretty much everything you needed to build came to you at a station that was basically a pole with a screen, the tools, and the product moved from station to station on an AGV. It was in part for this company a showcase line, which really came out really beautiful. Which, by the way, we did in cooperation with our friends at Toyota Material Handling. They provided the gear, and we provided the line design know-how. This is
right. And I love the analogy that Tom mentioned yesterday. Imagine if you were in an operating room and you roll a cart up to the operating table with every instrument that the surgeon could possibly want to use, and just say, "Hey, this is super flexible. You just pick the instrument you need. Help yourself, self-service." Well, the amount of time and potential errors that you'd be introducing would be phenomenal. So the idea of the surgeon is the surgeon just extends his or her hand, and the surgical nurse puts that instrument right into their hand. That would be the ideal manufacturing. You're anxious to say something here, Gerard.
Wait a second. You don't need to imagine. Yeah. This did happen until one of our own came up with the solution. Back in the early 20th century, that's how surgeons operated. By having all the instruments next to them and rifling through the instruments to get to what they needed. Until one Frank Gilbreth noticed, because Henry Ford asked him to observe, that while the surgeon was rifling through the instrument set looking for what he needed, the patient was bleeding. So he said, "This is really bad. We need a solution." So he came up with a solution that to this day existed, and he published this in 1914. To this day, that role existed, and it's called the scrub nurse. Now the scrub tech. And at that time, and this is a joke, and this is a story I tell all my clients in hospitals. This is one of our specialties, the design of perioperative services department. And every time I talk to surgical nurses, scrub nurses, I tell them, this was one of us. And by the way, the name he came up with for the scrub nurses at the time was actually delightful. It's not used anymore because it's just horrible. He referred to them as the surgical caddy. The surgical caddy. So it did happen. So it was tried. It wasn't good.
All righty, next one. Mistake number 5, jumping to CAD too soon. We don't need to beat a dead horse too hard here, but the idea is this. When you're designing a building, a house, or an assembly line, you want to take some time to experiment and try different scenarios and try out different things. And if it's too hard to do that, too hard to change things and experiment, then you're going to be tempted to just settle on a design or a particular scenario potentially too soon, sooner than you should have. And so if you fire up a CAD system and start doing a layout as part of your design process too soon, now, eventually, of course, you need a detailed, dimensionally correct document. But if you start too soon, what's going to happen is at some point, the effort to move things around and change things because you've added so much detail to your CAD drawing is going to reach the point where you're going to be disincentivized to experiment, right, and try things. So what you want to do is keep things at the model level, at the flexible level for a fairly long time so that you can easily move things around. And by model, I mean primarily it would be some manual model like Post-it notes or cutouts or paper dolls. But a little bit later on in the process, that model could be a computer simulation model as well. But either way, you're not committing yourself to something that's too solid prematurely. Now, of course, yes, eventually you're going to reach a consensus and you're going to have a detailed design. Just like if you're building a house, you're going to have some sketches, you're going to have some different scenarios the architect will present to you, you'll explore, and then at some point you need to have detailed architectural drawings, right? So same analogy. So why are we mentioning this? Well, I'm mentioning this because I worked on a project, more than one, but one that sticks in my mind where the team leader was really good at CAD, very comfortable with AutoCAD. And so day one, this person, just out of habit, I guess, fired up AutoCAD and started doing, scenarios and started working AutoCAD from the start. And I could tell, but it became almost too late to change it. But I could tell that we were committing to particular scenarios way too early. So again, we're giving you this warning: stay away from AutoCAD until you've reached team consensus and had a chance to explore various options, and then you can nail it down. Correct?
Yeah, and that's what we teach in class. Resource calculation, data gathering, resource calculations, conceptual design, ignoring all constraints, then use that conceptual design for the computer simulation and for CAD. So that's the story that Richard just told. Don't fire up CAD too soon. And when you do, get yourself a very patient CAD operator, because you're going to be asking for changes.
Yep.
And better to do it interactively, by the way. Don't give him something and say, go do CAD and come back. Do it as a team interactively. It works way better. This is another one, not using IPKs. In other words, being dogmatic. What's an IPK? IPK short for in-process Kanban, which is a parking spot for a product between two workstations. So you do the work at the workstation. Before you go to the next workstation, you have a parking spot between the two. Why is that there? To aid in the balancing. It provides you one takt time of, I like to say, of slack, right? Between the two stations, gives you more flexibility. To the untrained eye that has taken a couple of classes and things that they're looking for Muda everywhere, they look at that and say, well, that's waste, right? And they don't realize that sometimes the variability in the work that comes from product variability and human variability, it makes that in-process Kanban necessary. We do understand that for some of you, it's easy to put in place an in-process Kanban if you make something like this. But if you make fork trucks, kind of difficult to put in-process Kanbans on that line, right? But if you can afford it, in-process Kanbans are a very good tool for balancing. As a matter of fact, they are one of the balancing techniques we do teach. So they are space for the partially completed unit. They act as the demand signal for trigger flexing, and if used judiciously, they are not waste. They are an excellent balancing tool. So solution, first of all, learn what an IPK is, learn how to use it. They become less useful the longer the takt time, the shorter the takt time, they can become more useful. Default is always 1, but you can take them out. And one great thing about simulation, you can add and subtract IPKs and see the impact on the line volume. So definitely using computer simulation for this is great.
Okay. So case history on IPKs. By the way, if you ever run across people that are using the term IPK, chances are really high that somewhere along the line in their history they got trained by us or our school of thought, right? People that have gone through this particular style of lean, because it's a little bit unique. I think I think it's a Toyota term, in-process Kanban, but you don't hear it used that much, other than people that have been taught to use it, like people that have gone to our classes. In any case,
and normally, if the IPK is horizontal, likely there's an IPK. If the IPK is vertical or piling, that's a pile of junk. That's not an IPK.
Right. So IPK, aka buffer. The case history or the story was that a group of people were sent to Japan that I know of. In fact, a friend of mine was part of this team to learn about lean, learn about the Toyota production system as well. And so part of their training was to design a fairly simple line, but design an assembly line in teams. And it was a competition. So they would design it, and then they would actually run these, I think manually, right? Build products in a simulation environment and see who could do the best job. And by best, we mean, achieve the best throughput, utilization, et cetera. So some of the teams in this class chose the, say, dogmatic approach or the no waste approach, and regarding buffers or IPKs as a form of waste, and not including them, right? Not including them in their design. And this was a mixed model challenge. But his team said, no, look, there's a law of the universe. It's a little bit like the law of thermodynamics. It's the law of system dynamics. And what that says is if you have variability, then you can help offset some of that variability, I mean, not all of it, by having buffers in the system. And this is testable with science, with simulation modeling. So they said, no, we don't want to leave these out. We realize that this is some additional inventory, but the benefit is going to be better performance of this line, which is it's going to more than offset that additional inventory. So they did that. And guess who won? The team with the buffers, with the in-process Kanbans, won in terms of performance, right? They blew away the competition. So the word here is, we understand that it's not always possible. Again, if you're building large products like fork trucks, you can't put space for an extra fork truck between every station. Or John Deere, tractors or combines, you're not going to double the length of the line by just adding a bunch of space. But if it's a smaller product where you can add buffers strategically, into that flow, you're going to get potentially much better line performance. Right.
But it's not an all or nothing. In some cases, even with large products, and I know because I am currently designing a line for large products, we do have IPKs. We just don't have them in between every workstation. It's not an all or nothing. And to me, the operating where there's judicious use of IPKs. And for that, I immediately reach for the simulation model, and I add and subtract IPKs, always with an eye on the ultimate throughput, and it works great.
All right, we're getting close to the end here. Number 3, too much line side material.
Yeah, we beat this one already pretty good, right?
Yeah.
And that is if you are still in the business of supplying replenishment materials to the associates on the floor in large quantities, in bulk, in pallets, in gaylords, start working to get out of that. There is no good reason to do that. And believe me, we've heard them all. And in no case is justified. Right? In some cases we hear, well, our variability is too high and we don't know what's needed until the last second. So what we need to have is everything under the sun, right? Depending on the product. All that can be worked out, folks. All that can be worked out with sequencing materials, with kits, with sets, with Kanban, but definitely not with bulk. So get out of that business, learn the techniques for material replenishment, set an ambitious target. You will hear from from Tom later tomorrow. You hear from Tom what is their target for the amount of materials on the floor, and you will see that they're not only aggressive, they also stay true to that. So get out of the business of delivering bulk stuff to the line, please. So this one, again, delivering the boxes, right? And we've seen this all the time. I think we've beat this one enough. Let's move on to the next, the penultimate mistake we want to discuss. Unless you have a story to that one, Richard, but we beat that one enough.
Well, if it's okay with Tom, I'll share my observations at Toyota, in this case, Toyota Georgetown. I was there a few years ago as part of a tour. And one of the things I noticed there was, and I don't know what's happening there today, but at least when I was there, they'd removed the line side material from many of their sub-assembly stations, like engine prep and dashboards. They'd removed line side material they're storing at the actual assembly stations almost completely, and delivering material via kits. Now, the kitting process was something that, again, I observed was taking place close by. But at the stations themselves, there was nothing other than the parts they needed for that unit that was right in front of them, which was quite remarkable.
Yeah, we're seeing, and we're leading also a migration away from Kanban. Please don't get me wrong. Kanban is awesome. It's a great technique. But when you overdo it, you end up with too much inventory.
Okay, this is a big one. Mistake number 2, overstaffing.
A well-designed and well-balanced line is likely to have some empty workstations. And if you overstaff a line, you will see the principle of diminishing marginal returns live right in front of your eyes. How can it be that the more people I add, the less volume I get? Principle of diminishing marginal returns, overstaffing, and many times that comes from an untrained line supervisor, line manager, right? They haven't been trained, they haven't been properly educated. They panic at the first sign of trouble and they throw people at the line. The more people, the less volume, the more trouble. Now, you have to properly staff the line, but overstaffing, that is an enormous amount of waste. So understand the imbalances, work really hard to balance the line properly, but don't think that every station must have a person. Now, there are masters at balancing, some masters at balancing, like at Toyota. At Toyota, their balancing is so incredibly fine that you're likely to see a person at every station. But the quality of their data and their balancing is not common. So when that is not possible, we rely much more on understaffing the line and using flexing and IPKs.
All right. So we just mentioned this book here. This is a book put out by, I think it's
not one of our books.
Productivity. No, it's not one of ours.
Books?
Yeah, missing an opportunity here. I mentioned this book because there's a section in here. There's a chapter in here on what we call flexing or variable staffing, and the concept, in a nutshell, the concept is if people have room to move, they can continue to add value, even if it's not at their station. But as the line fills up, the ability to move out of your station is reduced, obviously, because someone's already there on your left and on your right in the flow. So you have no option other than to just wait if you can't actually work on something in front of you. And so that's the issue that's documented quite well in this book.
Yeah, which, by the way, when we teach, we do teach flexing in class. We do teach flexing when we teach class at Toyota, but we just don't have the time to do it justice. We teach it in maybe 10, 12 minutes, right? Because, there's only so much time we have. So for that reason, for those of you who are members of the Lean Science Studio, there is what we're calling a graduate level course, which is available for free to all of you members of Lean Science Studio. 90 minutes of just flexing. 90 minutes of just flexing, because again, you cannot cover that on the main mixed model line design class. So
yeah, by the way, right across the highway from Toyota Material Handling is a company you're also familiar with, I'm sure, a famous company called Cummins, where they make the diesel engines for the Dodge Ram. I think that's the plant where they do that. Tom can correct me. I think that's correct. So I was over there since I was in the neighborhood on occasion, and they invited me over to take a tour. And so we were talking about this issue of staffing, and they said, yeah, we typically staff for the first shift at 100%, and we can't get enough people, or we don't fully staff the second shift. So we have maybe 75% staffing or so on second shift. And I said, well, how's the output, right, on the one shift compared to another? And they said, well, that's a strange thing. We get as many engines out on the second shift as we do on the first. I said, case in point, right? I rest my case, Your Honor.
Thank you for making my point.
So what's happening on the first shift? Well, you have about 25% waiting time. And it's pretty easy to see that as well. If you just, draw a circle in chalk on the floor and watch. Because, sometimes you don't have an engine in front of you. Or sometimes you have a finished engine in front of you and you can't move it out of your station. And that happens less on the second shift. Okay, well, we'll move on. But this is a really important subject. By the way, last comment on flexing. There's a book by Gordon Gerard. He's a colleague of ours. Wrote a book on this subject of flexing. And in his experience, because he kind of specializes in this, he has, not rarely, but he claims he has never seen less than a 30% productivity jump when they went to a flexing kind of strategy, which is a lot. This is not.
We rarely promise that kind of productivity improvement, but we never not see. That's a double negative. we never not see improvements, productivity improvement from flexing. Not flexing is leaving money on the table, basically. And again, that requires zero investment other than training your folks and monitoring the line. You're leaving money on the table. So, okay, so I mentioned this one already. Again, for those of you who are members of the Lean Design Studio, this is available to you.
Okay. And number 1, not testing mix and volume.
Yes.
Big one.
When you design a line, people like to say you design to customer demand. That's a misnomer. Like Tom was saying yesterday, this is a sit-down cushion truck, right? And cushion is a misnomer. Same here, it's a misnomer. You design a line for an assumption of mix and volume that resembles customer demand. But customers change their demand every day. And you cannot design for a constantly changing demand. So you design for an assumption of mix and volume. And what you need to do is to use the techniques, the balancing techniques we teach in class and the resource calculations we teach in class to come up with what we call the paper design, right? Design on paper, and then you have to test it. How do you test it? Well, we test it using simulation modeling. And in simulation modeling, what we do is we say, okay, first let's run this line design with the design volume. So you take exactly the mix that you use for your calculations and you run it through. And what you do is you say, if we design the line for 122 products, we run the model, did we get 122? So if you are in the ballpark, plus minus a couple of percentage points within those 122, now that's good. And then you say, well, what's the probability that the clients will order these 122 exactly in this mix? Not very high. So what you do is you start coming up with scenarios and run them through the model. Another scenario and run it through the model. And what you always aiming for is, am I getting my 122? Am I getting my 122? Am I getting more? Am I getting less? Because you may say, what if we only put the lower work content product? The volume should go up. What we put mostly the high work content product? Volume should go down. Can we mix this 2 shorts for 1 long, 2 short for 1 long, 2 short for 1 long, and you test that? Well, what if today we got a more lows and fewer longs? So you go 3 shorts and 1 long, 3 shorts and 1 long, and you test it again. You have to test your assumptions. And whenever the model tells you, hey, listen, I'm not giving you the 122, then you make a decision. Do I add a workstation? Do I subtract a workstation? Do I add IPKs? Do I add an extra process here? Yes, no. And that is one thing that the simulation model will give you. It is really, to our line designs right now, the way we support our clients, it's a must. That's the way we do it.
You know, and when we use the term simulation, a lot of lean folks, oftentimes what they hear is like paper, desktop simulations or Lego type simulations.
And
that's not what we're talking about. Let's be clear. We're talking about discrete event computer simulation modeling. Where you can actually run hours, days, or weeks of production in a simulated environment to test that robustness of the design.
Now, for those of you who are thinking, well, now they are the consultants telling us to go spend $20,000 on a computer simulation software, and that's going to take years and years of training. We understand that. We tried to start with. As a matter of fact, Richard worked at one point for a company trying to doing computer simulation, right? So what we decided to do was to say, and again, we tried this. We went to all the computer simulation companies and say, can you help us out? And all they wanted to do was to use their system that can simulate levels of detail that we don't need. So we ended up working with one of our friends, Dr. Gerard Kaplan, who wrote a simulation package for us, and then we took that simulation package and we had it, a company rewrite that for us, so it's available online. That's what we use. Yes, it is simple simulation. We cannot simulate, the tides and the face of the moon while we're running product. No, it is a simple simulation model. But what would you say, Richard? In 2 hours you can learn it?
Yeah, I mean, we have all the training videos.
We have all the training videos
yeah.
in our system, and it's free to all of you that are members of the Lean Design Studio. So if you're a member of the Lean Design Studio, please learn how to use it, because it's an invaluable tool and it's free there for you. And what do we have? 16 training videos easily that cover many of the aspects of computer simulation. That's a very good point that Richard's making, because people talk about simulation. Let's go build paper airplanes. Building paper airplanes, a lot of fun. Not a simulation. No, not computer simulation.
Yeah, and the other pushback I get in talking to lean folks, like most of you listening, is, well, computer simulation is not really a lean tool. What we need to do as lean practitioners is get out to the factory floor, go to the Gemba, right, and work on problems and talking to people and not building models like that. But our slogan, and there's a great book called Serious Play, and the slogan there was talking about computer modeling, and the slogan was, whoever builds the best models wins in the future. In the future, whoever can build the best models is going to win. If you are a weather reporter, what do they call it, climatologist, you're building models, right, to try to predict the future. And the more sophisticated these models, the more successful you are in terms of anticipating a hurricane and letting people know what's happening. Well, same thing with a factory as well. And in case you're thinking that this is an unlean thing to do, I was talking to a sales rep for one of the leading simulation modeling companies, like one of the top 5 probably. And he said to me, in the last couple of years, we've been doing a lot of business with the world of lean. In fact, our biggest customer these days is a company you probably heard of. And I said, oh, really? Who is that? And they said, Toyota is one of our biggest customers. And they didn't used to be, and again, this is probably a couple years ago that I had this conversation. He said they didn't used to be, but now they're getting into it in a big way. So that's just anecdotal evidence. But if you thought that simulation modeling was unlean, well, our friends at Toyota are adopting it in a major way.
Listen, I don't mean to toot my own horn, but I'm a very good line designer. I know what I'm doing when I'm designing a line. I can walk a floor and give you a pretty accurate description of what that line is going to look like when I'm done with it. But pretty much always, when I run a simulation model, I always learn something. Again, folks, I've been at it for 30 years, so I know what I'm talking about, right? But when I run a simulation model, I always learn something. Maybe one extra workstation. Maybe one extra IPK. Maybe, this IPK, I thought I needed. No, I'm not going to need it. And save space. I always learn something from the simulation model. So my recommendation is, especially since for many of you it's free, use it.
And the final comment is the worst time to be making changes of a major type is, of course, when you've already implemented the line. That's the most expensive, the most costly, the most painful time to have to be making changes. So,
you remember, Richard, that faucet factory with such a short takt time that should have been 2 IPKs in between each station, and there was only one. Well, day one wasn't a very happy thing, right? And adding those extra IPKs, we did it, But I'm telling you, had we built a simulation model of that line, which was a pretty simple line, we wouldn't have had that bad first day. So,
Yep. Okay, so I think we've reached the end here.
yes,
Tom,
so
are you still with
ready
us?
to teleport to Columbus.
I am still here.
Still awake?
I am still here and still awake. Yeah. Looking forward to showing you around a little bit here, folks.
Okay.
Excellent. So we're going to the same trick as yesterday.